More time to talk about slope. So you might remember back in chapter 3, section 1, we looked at equations and figured out how to determine if they were linear or not. We looked for red flags like having exponents or variables being multiplied together, different things like that. They were indications that those functions were not linear. Today, instead of talking about equations and whether they're linear or not, the first thing we're going to do in this lesson is talk about how we can determine if a table like these down here is representing a linear function or not. So the cool part about linear functions is their slope, which is their rate of change, is constant, it's unchanging. So that means the rate of change should be constant all the time. So you can read through this fully if you want, but I think it's easier if I just explain it with the example. To figure out if a table is linear or not, I need to look and see how both the x values and the y values change as each point moves. In other words, to move from 16 to 11, they went down 5. We move from 11 to 5, that moves down 6. 5 to 0, that's moving down 5. 0 to negative 5 is moving down 5. So right here, we actually already know this one is not linear. Because to be linear, the x would need to be going down by 5 every time. So since at this spot it goes down by 6 instead of 5, that means it's a no-go. Now, once you see a problem, you can stop and say it's nonlinear and move on. But just for practice, I am going to do the y values over here just so you see how that works. So negative 8 to negative 5, that moves up 3. Negative 5 to negative 2 moves up 3. Up 3, up 3. So the y's do move with a consistent pattern. The y's are acting like they're linear. However, the x's are not. And both, as it says right up here, both the x and y values have to move in a linear, consistent fashion in order for it to be a linear function. So as soon as you see one of them doesn't work, you can say, no good. So let's follow the same pattern over here, this one. Starts at 0, then goes up 2, from 2, up 2, up 2, up 2. So the x's are behaving. I say they're behaving. Just say they're behaving in a linear fashion. Things are allowed to be nonlinear. But these are linear because they're consistent every time. For the y's, we go down 6, down 6, down 6, down 6. So both the x and the y are behaving in a linear, constant change pattern. So yes, this is linear. Now I just want to make sure it's clear. When I look at how the x's change, these numbers do have to be identical. When I look at how the y's change, these numbers do have to be identical. But it's completely fine if x has a different motion than y. These two lines don't have to be the same as each other. They just have to be the same number all down this line and the same number all down this line. Okay, this is no different, just sometimes they put tables in a horizontal fashion instead of vertical. But still the same process. We're going up 1, up 1, up 1, up 2. So I already know this is a problem. But just for fun, let's go down and look at the y's. It goes up 4, up 4, up 4. Ooh, it also has a problem. It goes up 5. So this is a no-go. This is nonlinear because the x's and y's don't move or change in a constant repeating pattern. Okay, now normally when we talk about slope in the slope equation, they just give you 2 points. I'm just making up some numbers. Doesn't matter what they are at the moment. But they give you those 2 points and they say, find the slope between those 2 points. So the points are the things you know, and the slope is the thing you don't know. But there can be times where they'll actually tell you the slope. Maybe they say it's -3, but then they hide one of the points from you and say, What does that have to be so that the slope between these two is -3? So here's an example just to help you understand why, because truthfully, all the ones in the book and such, they're just problems just like this, very rote, very just calculate. But I wanted to try to explain why this could be helpful and show you something you're doing. So maybe you have one piece of data, but you also have a goal. You're trying to figure out how to achieve that goal. Let's say you've played 2 basketball games so far this season. So far, you've scored a total of 30 points. So it wasn't 30 points per game. It was when you add your points from the first game and the second game together, it totaled 30 points. Now, you'd like to continue averaging 15 points a game, and you're hoping to reach the goal of having the school record for number of total points in a season, which is 135. So you're wanting to know, if I can keep going at 15 points a game, how many games will it take for me to reach that record of 135 total points? So to do that, we'll treat the number of games as our x value. So 2 games, total points is the y value, 30. So after 2 games, scored 30 points total. And after how many games will I have scored 135 points total? Assuming my rate of change is 15 points per game. So to figure this out, we use the slope formula. And we plug in what they gave us. Well, they gave us the slope, so normally we're looking for m, but this time we know m. It's 15. Our y2 is 135. Our y1 is 30. Our x2 is x. Our x1 is 2. So if you need to pause to make sure you catch up with me, you can. That'd be the setup. And we're trying to solve for x. We want to know, what is the game number when I will reach that total? So we can't solve for x when it's in the denominator. We've got to get it out of there. And to move something out of a denominator, you multiply both sides by it. So this x minus 2 can't be separated. This is dividing the whole of x minus 2. So we have to multiply both sides by the whole of x minus 2. So here we get 15 times x minus 2. And then I'll go ahead and subtract these. 135 minus 30 is 105. If you want to distribute the 15, that will definitely work. I'm going to choose, though, to divide both sides by 15 instead. But if you want to distribute and solve it that way, that is 100% fine. So this leaves just x minus 2. 105 divided by 15 is 7. Then we add 2 to both sides, and we get x equals 9. So that means at the end of the 9th game that I played this season, I should have hit the record I wanted to of 135 total points. So if we have the information of 2 games is 30 total points, and 9 games leads to 135 total points, that will be a slope or an average of 15 points per game. So let's take that same logic and compute these down here. So they've given us the 2 points, and they use r. It doesn't really matter what variable they use, but that's the one our book uses, so I stuck with that. And you plug in your slope. So I say 1 equals y2 minus y1 over x2 minus x1. So this one has the same pattern as the first example I showed. The r is on the bottom, so I'll multiply both sides by r minus 6 to get it out. Okay, well, r minus 6 times 1 is just r minus 6, so no reason to have parentheses or distribute anything there. Negative 2 minus 8 is negative 10. So next we will add 6 to both sides, get r equals negative 4. Okay, number 2 is going to be similar. 3/4 is our slope. y2 minus y1 over x2 minus x1. You've got to remember, anytime you see minus and negative, you should change it to plus a positive. So another way we could write this is 3/4 equals r plus 3 7 plus 1 is 8. So what's different though about this one from the first two we've done is we've got a fraction equal to a fraction. Now there's more than one way you can approach this. You could just multiply both sides by 8. In fact, I'll show it both ways. You could just multiply both sides by 8 because you're trying to get r by itself. 8 times 3/4 is 6. We have r plus 3 left. So we just subtract 3 from both sides and get r equals 3. So that way's good. Another way you can approach it if you want to, I'll just rewrite what we had. We had a fraction equal to a fraction. So another way you can approach this is by cross multiplying. Just like we did with proportions, or you have done proportions in the past anyway, when you have a fraction equal to a fraction, you can cross multiply. So 4 times r plus 3 equals 3 times 8, which is 24. Then I divide both sides by 4. You could distribute if you wanted to, but I'm not going to. We get r plus 3 equals 6. We subtract 3 from both sides. You can see either way, we get r equals 3. So you can pick whether you just multiply by the denominator or you cross multiply. Okay, number 3. This one's a little bit different because the slope is 0. So we'll plug in 0 for the slope, do y2, which is the r, minus y1, which is negative 5, over x2 minus x1. So I'm going to go ahead and simplify some things on this right side before I go farther. So minus a negative changes to plus a positive. And 6 minus 7 is negative 1. So our goal is to get r by itself. So we need to get rid of this denominator. So we'll multiply both sides by negative 1. 0 times any number equals 0. If you have 0 negative ones, you have 0. Then we subtract 5 from both sides, and we get negative 5 equals r. Okay, last one. Our slope is 3/4. y2 minus y1 over x2 minus x1. Okay, so this one, I'll go ahead and simplify the 1 minus 4. So I'm going to choose to cross multiply on this one. So 3 times 7 minus r equals negative 3 times 4, which is negative 12. So like I said earlier, if you want to distribute, that's completely fine. I prefer to just divide both sides by 3 and get 7 minus r equals negative 4. So to get r by itself, I've got to get rid of that 7. It's a positive 7, so I'll subtract 7 from both sides. And I'll move my work up here now. So the 7's gone, leave me just negative r. Negative 4 minus 7 is negative 11. So we're close, but we can't have our answer as negative r equals. It has to be positive r equals. If there's no number written in front, there's an understood 1. So we can fix this by dividing both sides by negative 1. We get r equals positive 11.